Okay, so we're going to be going over the 7th chapter of the Kernighan-Ritchie C book today. The very first section is explaining things about the get char and how the standard input and standard output work and how does piping work. We're going to be looking into that in my last code example today instead of talking about it particularly. Then the following section, 7.2, explains in more detail how to use printf. We've been using printf to print things, but we've been mostly using the S and the D to print the strings and the decimal numbers. I'm going to put this screenshot on Discord as well so that we can have it at hand. And in your project, it's likely you're going to want to start to print also some more detailed things. Something, for example, like making the field be a specific width, printing leading zeros, figuring out how many decimals to print on a number that isn't an integer, etc. So that's all explained right under this table, how you can specify the width and how you can specify the precision for strings and numbers and everything. And the section 7.3 is really interesting. It explains how you can make a subroutine where you don't tell the computer beforehand what are the parameters that you're going to be passing to the subroutine, but it could have more. So please read that if you're interested in how to make in C a subroutine where you don't know beforehand how many parameters it's going to take. Our first point of interest today is going to be the use of the scanf function, which is a formatted scanning that's going to replace some of the functionality that we have for getting characters out of standard input. But now I have to move the Discord to the other window because somebody is still sending me information on the points they got in the homework. This all should have already concluded a long time ago. But some people just like to make everybody stop because they are special. Okay, returning. Okay, so we're going to go to the chapter 7 codes, and we're going to be looking at first the scanf example, which is called entrada.c and also entrada.h. I like the dark mode, so let's look at them here on GitHub first. So what do I have in the H file? I have a structure that combines a string that's going to be a study program, a string that's going to be username of a student, and an unsigned int number that's going to be the student number. So students are going to have this information. Then what our C code is doing is going to be creating a storage of users with this structure. We have two definitions here. We have a PE and a UName. This means that the study programs are going to be 3 character strings and the usernames won't exceed 8 characters. What we are going to do first is ask the user how many students are there going to be. Now we're going to use the scanf. We're going to say that what the user is going to be typing will be one single integer number. And I would like it stored at the pointer that goes towards count. But since count isn't a pointer here, count is an integer variable, I'm going to use the ampersand to convert it into an address because scanf needs to modify the value of count. So it needs to get the address or an integer pointer. You cannot just give it an integer because it needs to modify the memory. Then once we've told the program how many students we're going to have, it's first going to allocate space for that many pointers. Then it's going to start a for loop to allocate those students one at a time then asking what are the student ID number, study program, and username going to be. I am going to reserve space for the program and the username as well to illustrate the use of malloc. Take into account that I'm reserving one extra character so that the null termination character fits into the string. So it can be 3 letters and the null terminator. Then we're using scanf for a second time. I'm saying that the user will now type me 3 things. The first one's going to be an unsigned integer. Then there's going to be a space. Then there's going to be the study program. Then there's going to be the username. And I am passing here pointers to the fields in the structure. And why does this one have an ampersand and these ones don't? These are already pointers because they're strings, and strings are character pointers. This one was an unsigned integer, so it's not a pointer, and I need to give the address. When I'm done scanning the information, just to see that it's actually correctly stored, I'm going to iterate over that same array of the student structures and printing out that information. While I print out, I'm also liberating the memory. First, I liberate the program and the username strings. Then I liberate the user itself. And at the end, I liberate the array in which the users live. Let me make a terminal window so we can try this out. So let's go to the folder here. Let's compile, come on, entrada, and start to interact with this lovely program. So how many students are there? There are going to be 2 students. So now I need the student ID number, 1, 2, 3. What's the study program? Software engineering. And what's the username? Elisa. Okay, now ID number for the second person is going to be a electronics and communication engineer, and his name's going to be Juan. Okay, so this looks all fine and mighty and lovely and wonderful. And now I'm going to show you what's going to happen in the real world. People are going to do dumb shit with your programs. They're going to type stuff like -1. Then nothing really happens here. So this wasn't that serious. The 4 just didn't do anything because there were -1 students. Let's try another one to be a stupid user. I typed 3. 3 evaluates to 0 because it's trying to read an integer, but I wrote letters and integers don't have letters. I can make this so much worse though. There are 3 students. What's the student's ID number? Hello, what's the study program? Something. And what's the username? Very long name. Okay, you can see that I have now entirely broken the program. It tried to read an integer and it wasn't able to. I wrote stuff that didn't fit anywhere. So not even the first student got done correctly, but because of the erroneous input, all of the rest of the program broke too. So scanf is more convenient for you as a programmer, but it's much more fragile because with getchar, you just take the character and you can easily add validations. Like, is this a digit? Is this a negative value? What does this value do? But when you're trusting the student, not the student, you're trusting the user to follow a specific format, then you're taking the risk that they will type erroneous things. Scanf is really good if your user is actually a computer. If it's a computer producing a file that you're parsing, all of this is wonderful because computers usually do what they're supposed to do. People usually don't do what they're supposed to do. So if you're asking for a person to type you a number, you probably don't want to scanf a number. You probably want to take a string input anyway, because they might write 3 with letters and they might put a number that wasn't correct. And you're going to need to see what did they write and then put an error message if it's not the correct thing. So don't use scanf if your user isn't reliable. You can't trust other people to remember whether to put spaces or tabs and how long the strings can be. And then when they come back saying that your program doesn't work, it's your fault. You are using scanf. and they didn't understand how to use it. You put them in that position. So be very careful with this. So it's very nice because we can read several things at a time. We can tell it what types those things are going to have, but we can't really trust it. Bad things happen when we trust it. Let's make a poll on whether we are semi-okay with what's going on with scanf. Okay, seems to be understood. So now, another very lovely thing we're learning in this chapter, there's actually a separate table for the scanf conversions, and it's sometimes a little bit confusing because it's not always exactly the same as the printf conversions, but I think our reference card should have both of them. I'm also posting this one on Discord and then returning to the other wonderful thing that I wanted to talk about. The other wonderful thing that we're learning to do today is working with files. Because up until now, we've just been typing everything that the program takes as input. And especially when you're debugging, this gets tiresome like really quickly. You would really just want to try your program over and over again and not having to type anything to it. So now let's suppose we have a data file like this one, datos.txt. Let's look at it here. So I have this data file. It has 3 rows, ID number, study program, username. So now I would like to make a program that's similar to the one that we just had, but instead of the person having to type the things, we're going to make the program read the things. And this is already in the repository as well. We can look at it there, or we can look at it on my computer. It's going to be the Archivo. I believe it's Archivo. Let's look at Archivo. So I'm still using the same structure. I still have the same length limitations, and I'm still putting everything in the main routine. I am using a character first because I'm going to do a very funky thing. In order to store the student information, the program needs to know how many students there are. But if you remember the file here, the file isn't saying how many there are. They're just 1 per row, right? So it doesn't tell us how many there are. So what do we need to do? I am first going to read the entire file to count how many line changes there are. Then, when I know how many there were, that means I know how many students I have, then I'm going to rewind the file pointer to the beginning. So this is actually now a pointer to a file, and yes, it's in uppercase, the file part. You need to tell it that you would like to open this file. This is the name of the file, and this is the access mode. R means reading, W is going to mean writing, A is going to mean appending to the end of the file, and then there's a B for when you want to use a binary format. So we're going to open datos.txt for reading. We're going to read it all to find out how many lines there are. Then we're going to rewind to the beginning. Then, since we know how many students there are, we're going to start reading again. Now, instead of using a scanf, I'm using an fscanf. Scanf was a scan a formatted thing, and now I'm scanning from a file a formatted thing. First, I need to give it the pointer to the file. Then I need to give the format string, how's the information going to be structured, and then the pointers to all of those 3 things that I would like to be reading. The rest of the program is doing the same thing as before. Here I'm closing the file. Closing the file is like freeing the memory. It's very important that if you open a file, you also close it so you don't bug out your operating system. I'm going to, again, iterate over the structure, print them, and clean them at the same time. So let's compile this one. So now it's reading the file. It found 3 students, and it printed out the information. Now, if I go here to datos.txt, I don't even have to recompile. It's going to find the 5 students because it's reading the file. So important parts in this example is we need to get a pointer to the file by opening it. If we need to know how many lines it has, we're just going to scan it first. Then we need to rewind because now the file pointer is pointing to the end of the file and we can't read from it anymore. But if we go back to the beginning, we can now read line by line because the fscanf is actually going to be reading until you get the enter. We're going to close the file, very important, and the rest of the example is as before. We're going to make another poll. Okay, one person is still processing this. Edgar, do you have any questions? Okay, Edgar's processing. And remember, if you're confused about scanf and opening files at the same time, then it might be a good idea to open the file and use the fgetc, because the fgetc is like our getchar, but it's reading from the file. So it's a more familiar thing. So you can practice that first, and then when you've understood scanf, then you can try using the fscanf when you already know what you're doing. In our third example today, we're going to be creating a file. So I'm going to open 2 different files. I'm going to open datos.txt for reading, and I am opening reorden.txt for writing. Now I'm not using the structures anymore, so I don't use the mallocs anymore. I just have recyclable fixed length character strings for all my information. And you can also notice that I'm not reading numbers anymore. I'm just reading strings. Why am I just reading strings? It's more robust to just read strings because you don't need to expect a specific format. It's just continuous letters. It doesn't have to have digits or anything in it. So I'm going to say that while fscanf returns 3 fields, I am going to print those 3 fields. And here I'm making a weird hack. if we look at datos.txt, actually, this is datos.txt, and username's the last one. So why am I doing it here? Why am I not doing it in the username? Let's see if I have to do it in the username too. And if this wasn't the thing I needed to do. Problem is that sometimes when you read stuff, you end up also reading the enter as a part of a string. And then when you print it out, it comes out weird. But let's see how this actually works now. Compiling Salida. So no, it entirely broke. Let's comment both of those out. What on earth have I broken here? That's datos. It's reading number PR username. Oh, I think the problem is that Margarita is a too long username. There it is. So let's look at what it wrote. It wrote all of this. It seems to be acting lovely now. I don't have any weird letters. Let's look at what it looks like here. Okay, I don't have any weird letters here either, so I don't have to do this. But if you start looking at like there being weird symbols at the end of strings, it might be because the operating system was reading a carriage return that wasn't a \n but some other thing. And then you see like a little like hat A's or hat R's or something. And just make sure that the last character of your string is the actual null terminator when that happens. But this seems to be working happily now. And I am actually converting the numbers to numbers when I print them out. So if they weren't numbers to begin with, they're going to turn into zeros in the output. Let's look at what this would look like. So now where I wrote LOL, it's actually going to show up as a 0 because it got converted into a number. If I don't want this to happen, if I want it to show as LOL, then I would need to make sure, that I don't convert it at any points to a number. Trying to remember how if-def works. I'm gonna have to Google how if-def works. What you can do is you can make definitions. I can't remember the syntax for the else. Let's go down to the if-def. It's elif and endif, okay? Elif, endif. Elif, endif. Okay? So what's going on in here? What am I doing now with this weird thing? If a variable called convert is defined, it's going to try to convert. If it's not defined, it's not going to try to convert. So now, if I compile it with the conversion defined, then I run it. I need to compile first. This is Salida, followed by the execution, followed by looking at the last line of reorder. Okay, so if I have the convert defined, I am going to get the 0. If I don't define convert, if I comment this out and redo it again, so it's not called elif. Oh, but it's not an elif, it's an it's just an else. It's just an else because it doesn't have a condition, sorry. There it goes. So now, since conversion wasn't defined, that part of the code wasn't even used. And it's actually kind of cool because like you can decide what actually enters your code. Like when convert isn't really defined, I think I can put like random stuff in here. And I think it's still going to compile because that part doesn't exist. But then if I put the definition back, now random stuff exists and it doesn't compile anymore. So this is a stronger thing than just a regular if in your code, because this thing determines what's even getting compiled. So if you need to write a program that, for example, sometimes prints debug output and sometimes doesn't, or sends a file to a different folder in Windows and on Mac, you can use the ifdef to compile into different executables for those different situations. So basically, the stuff that doesn't print out information for you, that could be like the production version, and the stuff that does, it could be like the debug version for your eyes only. So we could put here, for example, if debug is defined, we could be printing like a progress counter. And then when we've gotten them all, we could print an enter. I'm really good at putting single quotes because I write so much Python. So now we had the progress counter that was printing every single time we did something in the loop. If I take it out, if I don't want the debug output anymore, now I don't get the progress counter. Okay, so new things we're learning here. We're learning to also write to a file. We need to use the printf, but version f printf, and we need to mention the pointer of the file we're writing to. And when we're done, we're closing both files, the one we were reading from and the one we were writing to. I'm going to add this new version. I can't type. There it goes. So let's make another poll. Going to be two different polls. First, Paul, if we're okay with the printf thing, that we can send printout to a file with fprintf. And the second one, if we're okay with the fact that I can use defines and if-defs to do stuff if something is defined. There's also an if-ndef, which is the if not defined, that you could make it do the opposite thing. That if something isn't defined, then we include some extra code. This is all very fancy and very useful. Especially the part where you can print some stuff for yourself, but then you can easily hide it from the end user without having to comment all your print debugs, because you can just undefine the thing that controls the visibility of all the output that you've added. Looks like we're pretty okay. So I have one more example I want to talk to you guys about today. But first, we're going to make the computer's life a little bit easier. Remember when we were reading datos.txt, we first had to read the whole file to see how many records there are going to be. Then we had to read it again to read the data. If you're writing something for a computer, be nice. We could put on the first row how many records there are going to be, and then put the records, so that the computer only reads it one single time. So this would be like a nice thing to do, because you can cut the reading time to half when you don't have to read it twice. So my next example, error.c, is going to rely on the file having this format. There is a subroutine input. It does very much the same thing that our main did before. It's going to be reading into 3 fixed length strings. And it's first going to scanf for a count. And notice this is not a file scanf. I'm going to be reading from the standard output, but I'm going to be sending the file into the standard output because this is very interesting. Then if I got a count that was less than 1, I am going to print an error to the standard error, and then I'm going to exit. What does the exit do? Exit is stronger than return. Return only takes you back to the routine that's called this routine. So input would only go back to main if I do a return. But if I do an exit, it closes everything. The whole program stops when I do exit. If you're doing an exit, it would be very important to do any fclose or free that you have pending. But by the structure of this program, I'm not opening any files and I'm not reserving any memory that doesn't liberate itself. So I can just exit whenever I want. If the count was in fact larger or equal to 1, I'm going to start scanning the records in the format and printing them out to standard output. Then I'm returning the count, and then the main is going to put into the error stream how many records it processed, and then return a 0. So let's see what happens with this code. Let's run it manually first. Compiling. Running it manually. It doesn't say anything, but it's waiting to know how many students. Let's make 2 students. Doesn't say anything, again, because it's actually expecting to talk to a computer. It's expecting the 3 files, the number, that's actually going to be a string. Then it's waiting for the study program, and then the username. The number, study program, name. I think I broke something here. I think it was unhappy with my manual enter. Let's see if I can make it read Carla. Yeah, it's unhappy with when I manually press enter. So I would really need to use it like this, 2, and then I can't make it stop. I have to give it like output for some reason. I think it's probably this here. Let's try to compile without reading the enter. Try again. 2. First one's going to be 1, 2, 3. Okay, this looks much better. Then we're going to have the other one, 5, 6, 7. Yes, Carla. Okay, so now it's all happy and fine. Now we're going to try feeding the file to it. So I had this file called Facil. And what I am going to do is I'm going to run this program and I'm going to give it the file Facil. So you can see that it's now reading one by one the lines and it processed successfully the 3 records. So this is very nice. I don't have to write anything. I just send through standard input the information. So I'm not using fscanf because I'm reading from standard input as if I had typed it. And I am printing 2 standard output and 2 standard errors, because remember, this one goes to errors. How do I know it goes to errors? I could send my output somewhere else. I could send it to salida txt. So now what's in salida? It's only the stuff that was printed with printf. The stuff that was printed to stdr still shows up here. So now, if I use this other file that has wrong information, it's going to -2 in the beginning. If I send mal here, now it's going to complain and it's going to exit. It's never going to print the records process because it did the exit all the way up here. So it never did this for. And now my salida text is blank because I outputted nothing to it. Okay, another thing I could do is, if I just remember the syntaxes, I could send the errors to one file while I'm sending the output to another. So just this symbol sends standard output. The to and this symbol sends the errors as well. And there's another thing we can also do. If I put here Facil again, now let's see if I remember it right. I think if I put 2 of these things, now what happens is that instead of replacing the file, I've appended to the end of the file. So this is the execution with mal txt, and this is the execution with facil txt. And if I execute it again, now salida is going to have the double, and the error file is also going to have the double. Usually I would probably want the salida to be replaced and the errors to accumulate, so that I would always be looking at the latest output, but I would have like a record of all the logs of what has been happening in my system. I would usually include something like a timestamp to know at what time did these things happen. Okay, sending those in. Let's look at the poll to figure out if we're okay here. I linked a tutorial earlier today before you started grading on how to do this kind of stuff on Windows. What I am doing works as such on Mac and Linux. On Windows, if you want to do the same thing, you're going to need to install a bash shell. But most of this stuff is almost the same in Windows as well. I'll go find it for you guys and I'll pin it. I can't remember if I pinned it. I don't think I pinned it. This one. So all of that stuff is here. I've included the input files that I was using. I haven't included the output files because these programs generate the output files. So in my understanding, these are the important parts of the chapter. Let's make one final poll. Cats are gathering, they're getting hungry. I really recommend that while you're reading the chapter, you look at some of the useful functionality that's documented there. It's the same stuff that's in our reference card, but there's a little bit more explanation. I'm sending screenshots to the channel. There are the ones about strings that let you, for example, compare characters. Then there are the ones that have to do with characters, and what these are going to do is they're going to make it easier to know if what the user typed were actually numbers or letters or spaces or what. So that's also very helpful. There's this very cool function ungetC that sends a character back to the input. So if we read something and then we're like, oh my God, I don't want to read this, we can send it back and read it again later. And if you're confused about all this malloc and free stuff, the subsection 7.8.5 is about that. And then there's some math stuff that we could use, for example, to make our Polish calculator a little bit more potent. Also screenshotting those. Kind of hoping someone's going to pick some numerical algorithm or simulation or something as their project topic. And also the very last section mentions the random number generation that we were already using for our Minesweepers. Chapter 8 is going to be a slightly different kind of a chapter. It explains how a very old and powerful operating system called Unix works. And even though not many of us actually use Unix right now, many of the principles of how Unix works are present in modern operating systems. So these are very important things to know. And if you actually want to work as a high-end programmer or systems administrator or data scientist or anything, you need to be aware of these things anyway, because the computer you're going to be interacting with is probably just going to be a black box and a keyboard and text, because that's what real engineers do. Real engineers don't really sit around pressing buttons. They interact with command line interfaces very efficiently, and that knowledge requires knowledge of how Unix functions. So it would be really nice if you guys could try to find time to read chapter 8 before next class. But before we finish today, let's take a look at our assignments. Nobody seems to be in a huge panic here. Bunch of people need more time to process the standard output thing, that errors go somewhere else and that exit jumps out of the entire program, but you'll figure it out. It's not that horribly complicated. Let me find the Chrome to go look at the homework. Okay, so this is going to be the last exercise that's on the page. The very first one, when we're looking at it, we can try to start figuring out what's this going to have to do with the chapter we just read. There's a file opened here for reading. So this program is going to be reading something from a file. Then it's going to be closing the file. And we need two different expressions. One of them is going to control a while loop, and another one's going to be controlling an if clause. And here is an explanation of what the program's supposed to be doing. It's supposed to be reading data from a file that ends at a valid new line character, and includes things like student number, study program grade, student number, study program grade. Okay, so that's what it's going to do. So here we need to read all of the lines, and we need to make sure that we actually read formatted stuff like this. If the file line isn't like this, then we're not going to count it. In the second one, we're again opening a file for reading. We're going to be doing a little bit of a nastier way to check if we're done. We're just going to read the file until we're out of the file. And what's this thing going to do? We are going to read this same kind of a file that we're dealing with here. And we need to obtain what's the program and what's the grade of the person. So we have the same exact format for the student number, study program, and the grade. So you just need to write the fscanf statement here that actually reads into these variables. Remember that these two are pointers to begin with because they're arrays, and this one isn't, so you need to put the ampersand. So you get 1 point for this, 1 point for this, and 1 point for this. That's why there's only 2 codes. Then, actual homework. Let's look at this in more detail. So what we're going to do is that we're going to use a database, but our database is actually going to just be plain text files. You get to decide if you want to use one file or several files, but you need to design your file structure. Again, I would really recommend, even though I'm not requiring it, I'm really recommending it, that you first make pictures, drawings, designs of what you plan to do, and you post those in Discord, because I would like to think that when you made those, it actually made it easier to do the programming. So please consider doing this. What your programs be going to storing in the file-based database is records of when do people enter and exit work. So when we know when they entered and exited, we're going to be able to figure out how many hours they worked and if they arrived late. So each employee needs to have like a PIN code that when the person arrives, they type their PIN code, and then when they leave, they type their PIN code again. So when they type their PIN, you need to check what time it is. When they type the PIN again, you need to check what time it is again, so that you know that if they entered, then they exited. They entered, then they exited. You can suppose that the workday can't be longer than some certain time. So if they forgot to sign in or out, you're going to notice because they supposedly worked all night and that shouldn't be possible. I would recommend that don't actually make it work with hours because you don't want to be running your program for hours to test it. Let's pretend that these workers work like 8 seconds maximum. So you can just like make them work for a few seconds and then sign out again. What you're supposed to be tracking is what days of the week the employee is working. So you need to design like fake days of week if you're using the seconds. We could, for example, use the modulus of 7, so that whenever the second was like divisible by, no, actually not the second, like maybe that if the hour that you were using or the minute is divisible by 7, you're pretending it's a Monday. Some other thing is a Tuesday, etc. But you need to have like your artificial time so you can actually test this. And you need to track which days do they work, and you need to also track what time are they supposed to come to work. So if someone was supposed to start work at 8 and they started work at 9, you're going to know that they were late. If somebody was supposed to start work at 8 and they started at 7:50, you know that they're early. So you should be able to be capturing this information of when the people come and go. You should be able to, like from human resources point of view, determine when they're supposed to be working and what time are they supposed to be arriving. We should be able to generate reports that say how punctual they were, like which dates have they been attending, how many hours have they worked total, and we need to have some interface to register new employees. So we need to be able to say that we have this new person that's going to be, he's going to get this PIN, and the system's just going to generate a PIN that nobody has yet. And we're going to be able to define when is the person supposed to arrive to work and which days are they supposed to work. So you're making your tiny little human resources system for tracking who's working, when they're working, if they're late, how many hours they worked. Everybody's going to make their own design, and it would really be helpful if we could talk about these designs with some drawings on the Discord server. Then when we've started to see the drawings, we can talk about the grading for this one. This is going to be another 5-point exercise. Let's go look at the points here. So this one's our E7. It's going to be a 5-point exercise. And yes, I'm expecting there to be a .h file. Yes, I am expecting there to be subroutines. Yes, I am expecting there to be a way to start the program as human resources, or maybe have a separate main for human resources that creates the user, stores them in a file, and then a different program that the workers are running that's just writing the information of when they come to work and when they leave work. And then maybe the human resources program will be able to scan the information to see how much they worked. Or a third program could be doing that. They can either be routines in one single main, or you could have even a different main routine for different files for all of these 3 functionalities. So instead of just making a little program, we're trying to make a little software. And instead of the program just remembering things while it's running, we're going to be saving the state of the program in these database files so that when we run it again, we're going to continue from where we left off so that the users don't get erased. Their work doesn't get erased. But every time you run the program again, it just adds new information. So technically, when a person comes to work, they could run the program, put their PIN. When they leave work, they could run the program, put their PIN. The program doesn't have to be running all the time. And the human resources people, they could run the program like every time they hire somebody new. And the payroll people, they could run the program like every 15 days to make the paychecks. So this is much more complex than what you've done before, but most of this is just reading and writing information and calculating differences between times. Any questions at this point? Waiting for a little while. If there is no questions, I'm just going to end the stream and then we're going to talk on Discord. Edgar's writing. Okay, so now we're going to look at our reference card. How do we know what time it is? We're going to write time in the reference card. There is a header file time.h. It sounds very, very related to what's going on in here. So we're going to look at this part of the time and date functions. Guys, remember I've told you this little thing is your Bible. Everything that's on the reference card is allowed for the homework and the programs. Nothing that's not in the reference card should be in your programs. So if you're using libraries that aren't mentioned here, you are doing the wrong thing. I'm supposing you're just copying homework from some other group just doing some other thing, but you're not supposed to be using any other libraries than these. So how do we figure out what time it is? We can ask the processor time. We can calculate time differences in seconds. We can ask what's the local time. We can make it into a calendar time. We can make calendar times in the local times. We can get like times from strings. Play with this stuff. So now we know that there is a structure that represents time, and we can ask the computer what time it is and how much time has elapsed. So this should be really easy. You should be able to type, when did the person type the PIN when he came to work? then you should be able to type again when did the person type the pin when they went out. And you could just store this information in seconds, because then when they leave, you can subtract the leaving time from the arrival time, and you're going to know how many seconds they were there. If you don't want to calculate this in seconds, you could be dividing it by 60 to get the minutes, and then dividing that by 24 to get the hours. But since you're going to be speed testing this by yourself, you're probably going to want to pretend it's a freaking ant factory and everybody works seconds. But like the structure is really cool. Like you can figure out how many days it's passed since Sunday, how many days into the year are we, if or not daylight savings is in effect, all kinds of weird stuff. But you can just make an ant factory in seconds and not really worry about that too much. And if you have an ant factory in seconds, replace the concept of what days does the employee work with like what seconds do they work. Like the day for the ants could be a minute, and you could have an ant who works seconds 10 to 20, and another ant starts work at second 15 and leaves work at second 35. And every single minute, it's going to be a new day. So it's easier for you to test your program because you can test a whole week in 7 minutes. So it's entirely okay to imagine you're on a different planet or a different time scale, but as long as the functionality is there, that you're basically tracking when did they come to work, how long did they work, you should be fine. Any other questions? I'm going to close the file that has the points in it. I'm supposing everybody's already told me what points they got. Nobody's typing. I'm going to stop the stream, but I'm going to be on Discord for a few more minutes in case we have some disaster with the previous homeworks that we need to attend to, something you haven't understood, or some concern you have about this last homework assignment. So just please let me know. And if you do some designs, please do designs, please post them on Discord. And please try not to do it like the morning of the class, but like a couple of days before. Okay, we might get a question. Waiting a little while longer. And Daniela, this doesn't have to really look like anything specific. Your user should understand what they're supposed to do. And if you trust the human resources people to always type the right things, you could also use scanfs to read the entries. The workers, they only need to type their PIN code, so you can use getchar or whatnot, because the PIN code is going to be of a limited length. You're going to design this. Maybe 4 digits or something. 2 people are typing. We'll very soon have a cat on the keyboard. Guys, type faster. Freya's hungry. With the design, Edgar, I mean drawings of what you plan to do. I'm not talking about the user interface. I'm talking about your plan as a programmer. What subroutines do you think you're going to have? What files do you think you're going to have? What's the information going to look like in those files? Which program needs to open which file for writing? Which program needs to open which file for reading? It's like a software design, not graphic design. But let me stop the stream and then I can go play with Rule Gamer's tree notes to figure out what's wrong with the delete.